Beneath the glittering surface of the ocean lies a world that appears to be completely exposed. Sunlight pours through crystal-clear water, illuminating coral gardens in brilliant shades of red, gold, violet, and blue. Soft sea fans sway in the current, silver fish move across the reef, and white sand glows beneath the tropical sun. Yet hidden within this dazzling landscape are thousands of animals that remain almost impossible to see. They are not concealed behind walls or inside deep caves. Many are resting in plain sight, only a few centimeters from passing fish. Their greatest protection is not speed, strength, or armor. It is the ability to disappear. Camouflage beneath the sea is far more complex than simply matching the color of the surroundings. It is an extraordinary combination of pattern, texture, shape, movement, light, and behavior. For every animal living here, survival depends on seeing without being seen. Predators must remain hidden long enough to approach their prey. At the same time, smaller animals must avoid becoming visible to the hunters constantly searching the reef. This silent contest has continued for millions of years, producing some of the most remarkable adaptations in the natural world. Across the coral-covered seafloor, a small fish lies completely motionless among rocks, algae, and broken shells. Its skin is marked with irregular patches of brown, cream, and yellow. These patterns divide the outline of its body into smaller shapes. Instead of seeing a fish, the eye sees fragments of stone, sand, and shadow. Only the slightest movement of its eye reveals that something alive is hiding there. Nearby, a reef octopus presses its body against a coral-covered rock. Within its skin are millions of specialized pigment cells called chromatophores. By expanding and contracting these cells, the octopus can change its appearance in moments. But color is only the beginning. The octopus can also control the texture of its skin. Smooth skin can become rough and uneven, resembling coral rubble or an algae-covered stone. Small projections rise across its body, breaking apart its familiar shape. As it moves onto pale sand, its skin becomes lighter. When it reaches darker rocks, deep brown markings spread across its mantle and arms. The animal does not truly become sand, coral, or stone. Instead, it creates an illusion so convincing that the observer's brain fails to recognize the octopus hidden within the scene. For this master of disguise, camouflage is never a single fixed pattern. It is a constantly changing response to the world around it. Among the delicate branches of a crimson sea fan, another animal has taken a different evolutionary path. A pygmy seahorse, no larger than a human fingernail, grips the coral with its curled tail. Its body is covered with rounded bumps that closely resemble the polyps of its host. Its colors match the surrounding branches in shades of red, pink, orange, and yellow. Even when the seahorse is placed directly in the center of the scene, it remains extremely difficult to identify. It does not need to change its appearance from moment to moment. Its entire body has evolved to resemble the only home it knows. Across the reef floor, stillness becomes another form of invisibility. A stonefish rests among coral fragments, covered with mottled skin, algae, and grains of sand. Its broad head resembles an old rock that has remained on the seafloor for years. It does not chase fish through the reef. Instead, it waits. Small animals swim nearby, unaware that a predator is lying directly beneath them. By remaining motionless, the stonefish allows the restless reef to move around its body. But in an environment where seaweed, soft coral, and seagrass are constantly swaying, complete stillness can sometimes attract attention. Other animals survive by moving exactly like their surroundings. A leaf scorpionfish rocks gently from side to side, imitating a loose fragment of algae caught in the current. A slender pipefish holds its body vertically among seagrass blades, drifting whenever the plants move. These animals do not merely resemble their surroundings in color and shape. They imitate the rhythm of the environment itself. Motion, when perfectly controlled, becomes another layer of disguise. Sunlight also plays an important role. As waves move across the surface, shifting patterns of light and shadow travel over the seafloor. Many reef fish are covered with stripes, spots, and irregular bands that blend into these broken patterns. The markings disrupt the shape of the body. They make it difficult for a predator to determine where the head begins, where the tail ends, or in which direction the fish may escape. In the open water above the reef, camouflage takes a very different form. A vast school of silver fish turns as one. Each fish is clearly visible when swimming alone. But when thousands move together, their reflective scales create a constantly changing cloud of light. Individual bodies vanish inside the movement of the group. The school becomes a single shimmering organism, expanding, dividing, and folding through the blue water. Here, protection comes from numbers, reflection, speed, and perfect coordination. Some of the smallest ocean animals use an even more extreme solution. They become almost transparent. When light passes through clear tissue, there is little surface to reveal the outline of the body. Against the blue ocean, only the eyes and a few internal structures may remain visible. Tiny shrimp, larval fish, squid, and gelatinous creatures drift through the water like living ghosts. Transparency allows them to hide in a world with no rocks, plants, or coral to provide shelter. Every layer of the reef contains a different hidden community. Pygmy seahorses cling to coral fans. Gobies and shrimp disappear inside narrow crevices. Flatfish, rays, and buried predators vanish beneath the sand. Frogfish resemble colorful sponges, while decorator crabs cover themselves with living fragments collected from the reef. The longer we observe this landscape, the more crowded it becomes. The reef was never empty. Its inhabitants were simply too well hidden to be noticed. Camouflage is a silent conversation between light and darkness, movement and stillness, shape and perception. An animal may occupy the center of our vision, yet remain unseen, because every familiar clue to its identity has been concealed. In the ocean, survival does not always belong to the strongest or the fastest. Sometimes, the greatest advantage is simply not being detected. As sunlight continues to move across the coral reef, thousands of animals remain hidden in plain sight. They wait for the right moment to feed, escape, reproduce, or quietly disappear once again. And this is only the beginning. Ahead lie animals that can transform their color within seconds, creatures shaped like leaves, stones, and coral, and deep-sea inhabitants that use light itself to erase their shadows. In this underwater world, the invisible is rarely far away. It may already be directly in front of us. Across the sunlit reef, color is everywhere. Golden corals rise from the seafloor. Red sea fans sway in the current. Blue fish flash through clear water, while shadows move slowly across the rocks below. In such a vivid world, remaining hidden seems almost impossible. Yet some animals possess an extraordinary advantage. They are not limited to a single color or pattern. Their appearance can change from one moment to the next, responding to light, background, movement, and danger. These are the masters of changing color. Among the most remarkable is the reef octopus. As it moves across pale sand, its skin becomes soft beige, broken by faint brown markings. When it reaches a darker patch of coral rubble, deeper colors spread across its body. In only a few seconds, the animal seems to belong to an entirely different landscape. This transformation begins within the skin. Thousands of tiny pigment organs, known as chromatophores, lie beneath the surface. Each contains a small pocket of color surrounded by muscles. When the muscles contract, the pigment expands and becomes visible. When they relax, it shrinks again. By controlling many chromatophores at once, the octopus can produce complex patterns across its body. Dark patches may appear along the arms. Pale bands may cross the mantle. Spots can grow, fade, and return in rapid succession. But pigment alone cannot create every color. Beneath the chromatophores are other specialized structures that reflect and scatter light. Some produce shimmering blues and greens. Others create soft white tones. Together, these layers allow the skin to respond like a living screen. The effect is not random. The octopus constantly observes its surroundings through highly developed eyes. Its nervous system processes shapes, brightness, and contrast, then sends signals directly to the skin. Remarkably, much of this control happens without slow, conscious thought. The body reacts almost instantly. On smooth sand, the animal may choose a simple, even tone. Among broken coral, it produces a more complicated pattern. Where light and shadow alternate, the skin becomes divided into patches that disrupt the outline of the body. Color is being used not simply to match the background, but to confuse the eye. A predator searching the reef may see the pattern, yet fail to recognize the animal hidden within it. The octopus can also change texture. Small muscular structures beneath the skin raise and lower flexible projections known as papillae. In one moment, the animal appears smooth. In the next, its surface becomes rough and uneven, resembling coral, stone, or algae-covered rubble. Its familiar outline disappears. An arm may be positioned like a branch. The mantle may flatten against the seafloor. Even the eyes can be partially concealed by changes in posture and skin texture. The transformation is never perfect in every detail. The octopus does not truly become a rock, but it creates enough visual uncertainty to remain unnoticed. Nearby, a broad-club cuttlefish uses the same basic tools in a different way. It hovers above the reef using a delicate fin that runs along the edge of its body. Beneath the skin, chromatophores expand and contract in waves. Bands of color move across its mantle. Dark stripes appear, then dissolve into pale mottling. Sometimes the pattern changes slowly, matching the seafloor beneath it. At other times, the skin becomes active and dramatic. Pulses of light and color travel along the body like moving signals. For cuttlefish, color is not used only for camouflage. It can also communicate. A dark display may warn arrival. A lighter pattern may reduce aggression. During courtship, males can produce bold, contrasting signals visible from a distance. One side of the body may even display a pattern toward another cuttlefish, while the opposite side remains less noticeable. The skin becomes both disguise and language. Reef squid are equally skilled. Unlike octopuses, they spend much of their time in open water, where there are fewer solid surfaces to hide against. Their camouflage must respond to a constantly shifting world of blue water, surface glare, and moving shadows. When seen from above, the upper body may darken to match the depths below. When viewed from beneath, the underside remains pale against the brighter surface. This natural countershading helps reduce the animal's silhouette. As squid approach a reef, new patterns appear. Speckles, bars, and patches spread across the mantle, breaking the smooth shape of the body. A group of squid may change together, producing waves of color that pass from one individual to another. These changes can communicate alarm, social position, or readiness to mate. To human eyes, the display appears almost magical, but every flash is created by muscle, pigment, reflection, and precise control. Changing color also has limits. Movement can still reveal an animal. A sudden shadow may expose its outline. The background may be too complex to copy perfectly. For this reason, color change is combined with posture and behavior. An octopus may freeze against a rock. A cuttlefish may hover just above rippled sand. A squid may turn its body to reduce the visible outline. Successful camouflage depends on the entire animal. Color, texture, shape, position, and motion must work together. The reef is filled with animals wearing fixed patterns that have evolved over many generations. But cephalopods carry something more flexible. They can choose a new appearance within seconds. This ability allows them to cross many different habitats. They can move from sand to coral, from bright shallows to dark crevices, without remaining trapped inside a single disguise. Every background offers a new challenge, and every challenge produces a new pattern. As the sun shifts above the reef, the colors below continue to change. An octopus fades into stone. A cuttlefish becomes part of the sand. A squid disappears against the blue water. Then, With a single movement, the illusion breaks. For one brief moment, the hidden animal becomes visible. And just as quickly, it changes again. In this world of living color, camouflage is never still. It is a performance that continues every second of the day. Among the many animals hidden across the reef, few are as mysterious, intelligent, or adaptable as the octopus. At first glance, its body appears soft and vulnerable. It has no shell, no protective scales, and no rigid skeleton. Its arms move freely in every direction, and its skin seems exposed to the surrounding world. Yet this apparent weakness has become one of its greatest strengths. Without a fixed shape, the octopus can squeeze through narrow cracks, flatten itself against the seafloor, and reshape its outline to match almost any surface. Its entire body has become an instrument of concealment. A reef octopus moves slowly across pale coral rubble. Each arm explores the ground independently, guided by thousands of sensitive suckers. These suckers do more than grip. They can detect texture and chemical signals, allowing the octopus to examine the environment through touch and taste. As it crosses the reef, its skin changes constantly. Pale sand produces soft beige tones. Dark rocks bring deep brown patches. Red algae are answered with warmer colors, while broken coral creates an irregular pattern of light and shadow. The animal seems to borrow its appearance from everything it touches. But color alone is not enough. A smooth body resting on rough rock would still be easy to recognize. To complete the illusion, the octopus changes the surface of its skin. Flexible structures called papillae rise and fall across the mantle and arms. Some form small bumps. Others create long, branching projections. Within moments, smooth skin can become rough like stone, or uneven, like coral covered with algae. The transformation is extraordinary, but carefully controlled. The octopus does not copy every detail of the background. Instead, it selects the most important visual features: brightness, contrast, texture, the size and direction of surrounding shapes. By reproducing these elements, it creates an image convincing enough to confuse the eyes of both predators and prey. Even its posture becomes part of the disguise. An arm may be curled beneath the body to reduce its outline. Other arms may stretch outward like branches or pieces of drifting vegetation. The head can be lowered. The eyes can be partly hidden. The entire body may become broad and flat against the reef. Every movement changes the illusion. When danger approaches, the octopus often becomes completely still. This sudden stillness is not hesitation. It is strategy. Many predators detect movement more easily than color. By freezing, the octopus removes one of the strongest clues to its presence. A hunting fish may pass only a short distance away without recognizing the animal beneath it. But if the threat continues to approach, the octopus has other options. Its skin may darken dramatically. Bold patterns can appear across the body. The animal may rise from the seafloor, spread its arms, and make itself appear larger. Camouflage has now become warning. If this display fails, the octopus can release a cloud of ink. The dark cloud creates confusion, hiding the direction of escape while the animal propels itself away using a powerful jet of water. In only a few seconds, the octopus can change from invisible to dramatic, and then vanish into another part of the reef. Some species take disguise even further. Across the open sand of Southeast Asia, the mimic octopus lives in a habitat with few rocks or coral branches for shelter. Here, ordinary background matching is not always enough. Instead, the animal changes the way it moves and holds its arms. It may flatten itself close to the seafloor, drawing its arms together while displaying dark and pale bands. At another moment, it may raise several arms and allow them to drift with the current. These postures can resemble the general appearance or movement of other marine animals. The octopus does not literally transform into another species. Its anatomy remains unchanged. But by controlling pattern, posture, and motion, it creates uncertainty. A predator may hesitate because the shape before it no longer looks like familiar prey. That hesitation may be enough. Nearby, the closely related Wunderpuss octopus uses bold stripes and flexible movement in a similar way. Each individual carries a unique arrangement of markings, as distinctive as a fingerprint. Against pale sand, the contrast seems impossible to hide. Yet when the animal moves among shadows, shells, and scattered debris, the broken pattern disrupts its shape. Camouflage does not always mean becoming dull. Sometimes strong markings make the body harder to understand. Other octopuses use objects from the environment. A coconut octopus may shelter inside empty shells, carrying them across the seafloor before arranging them into a temporary refuge. This is not camouflage created by skin alone. It is concealment through intelligence and preparation. The animal recognizes useful objects, transports them, and saves them for future protection. Few invertebrates show such flexible problem-solving. Inside rocky crevices, larger octopuses use darkness as part of their disguise. A giant Pacific octopus may rest with most of its body hidden inside a den, leaving only an eye and a few arms visible. Its deep red or brown skin matches encrusting algae, sponges, and shadowed rock. Even an animal of great size can become difficult to detect when shape and background work together. The octopus possesses another remarkable advantage. Much of its nervous system is distributed throughout its arms. Each arm can perform complex movements and respond to local information with a degree of independence. While the eyes examine the wider environment, the arms explore nearby surfaces, adjust posture, and search for food. The result is a body capable of changing many parts of its appearance at once. One arm grips the rock. Another investigates a crevice. The skin changes pattern. The mantle controls breathing. The eyes continue watching. All of this happens together. The octopus is not simply wearing camouflage. It is continuously creating it. Yet this extraordinary ability requires energy and attention. No disguise is perfect, and no animal can remain hidden forever. A moving arm may reveal the body. A change in sunlight may expose the outline. A predator approaching from a different angle may see through the illusion. For this reason, the octopus is always observing. Its eyes are highly developed, capable of detecting contrast, shape, and polarized light. The animal studies the world before deciding how to disappear within it. As it moves from one part of the reef to another, each surface becomes a new problem. Smooth sand requires simplicity. Coral rubble demands a broken pattern. Seaweed requires movement. A dark crevice requires stillness and shadow. The solution changes from moment to moment. This flexibility allows the octopus to hunt, travel, and avoid danger across many different habitats. It can remain hidden beside prey, then move across exposed ground, then vanish again against a distant rock. Few animals can alter their appearance so completely and so quickly. As sunlight moves across the reef, the octopus continues its silent journey. For a moment, it appears as a patch of stone. Then it becomes a shadow, a cluster of algae, a fragment of coral. Only the careful movement of an eye reminds us that an intelligent animal is still there, watching the world from inside its changing disguise. Across the warm, shallow reef, a broad shape moves silently above the sand. A thin fin ripples along the edge of its body, carrying it forward with almost no effort. Its arms remain folded beneath the head, while two large eyes watch the water around it. This is the cuttlefish. A close relative of the octopus and squid, it possesses one of the most advanced camouflage systems in the ocean. As it crosses pale sand, its body becomes light and almost uniform. When it reaches coral rubble, dark patches and broken markings spread across its skin. The change can happen in less than a second. Thousands of tiny pigment organs, called chromatophores, lie beneath the surface of the skin. Each contains a small sac of color, surrounded by muscles. When these muscles contract, the pigment expands and becomes visible. When they relax, it disappears. By controlling many chromatophores at once, the cuttlefish can create spots, stripes, waves, and irregular patterns across its entire body. Beneath them are reflective cells that produce shimmering shades of blue, green, silver, and gold. Other cells scatter surrounding light, helping the animal match the brightness of the water and seafloor. Together, these layers turn its skin into a living display. Yet the cuttlefish does not copy every detail around it. Instead, it studies the overall structure of the background. Smooth sand produces a simple pattern. Small stones create fine modeling. Large pieces of coral cause bold patches to appear, breaking the body into separate shapes. The goal is not to become a perfect copy. It is to make the outline difficult to recognize. Texture is equally important. Small muscles can raise flexible projections across the skin. A smooth animal hovering above sand may become rough and uneven beside coral or rock. Its familiar form disappears. The head seems wider. The edges of the body become irregular. The arms resemble fragments of algae or broken reef. When it returns to open sand, the projections flatten again. The cuttlefish is constantly adjusting. Its unusual W-shaped pupils give it a wide view of the world. It can detect movement, contrast, brightness, and polarized light with remarkable precision. Although it may not see color as humans do, it can still match highly colorful surroundings. It reads the reef through patterns of light that remain invisible to us. Camouflage, however, is only one use of its extraordinary skin. Color is also a language. When two cuttlefish meet, dark bands may appear across their bodies. Pale areas become brighter, and the arms take on bold patterns. A male facing a rival may darken and enlarge his appearance, warning the other animal to keep its distance. Often, this visual display prevents a physical fight. During courtship, the signals become more delicate. Soft waves of color travel across the mantle as a male approaches a female. Bright markings appear around the head and arms, but other males may be watching. A smaller male can produce one pattern on the side facing the female and a different pattern on the side facing a rival. One side communicates courtship, the other reduces attention. The cuttlefish can display two messages at the same time. Its skin is controlled directly by the nervous system. Every stripe, flash, and wave is produced by rapid signals from the brain. The body can change before another animal has time to react. These patterns are also useful while hunting. A cuttlefish notices a small crab among coral fragments. It approaches slowly, matching the colors beneath it. Its body remains low, and the edge fin moves in gentle waves. As it draws closer, dark bands begin to pass across the mantle. The moving pattern may distract the crab or make the predator's distance harder to judge. The cuttlefish pauses. Two long feeding tentacles remain hidden between its arms. Then, in a single rapid movement, they extend forward. The action lasts only a moment. Soon the cuttlefish returns to stillness, and the bold display fades back into the soft pattern of the reef. Despite its skills, it is not invulnerable. Large fish, dolphins, sharks, seals, and seabirds may hunt cephalopods. When camouflage fails, the cuttlefish can darken suddenly, release a cloud of ink, and escape using jet propulsion. Water is forced from the mantle through a narrow funnel, sending the animal backward at high speed. But escape uses valuable energy. Whenever possible, hiding is safer. As daylight begins to fade, the reef changes. Bright colors soften. The white sand becomes blue-gray, and shadows stretch across the seafloor. The cuttlefish changes with the evening light. Its body darkens, the patterns become quieter. Reflective cells respond to the fading glow from above. For a moment, a pale wave passes across the mantle. Dark markings appear around the eyes. Then everything becomes still. The animal fades into the reef once more. Beneath the moving light of the sea, its skin is both disguise and language. Every color has a purpose. Every pattern carries information. and with every passing second, the cuttlefish becomes something new. In the gentle forests of the sea, survival often depends on looking less like an animal and more like a leaf. Long blades of kelp rise toward the sunlight. Red algae cover the rocks, while fragments of seagrass drift slowly with the current. Among this moving vegetation, unusual shapes begin to appear. At first, they seem to be nothing more than torn pieces of seaweed. But then, one of them turns its head. This is the leafy sea dragon. Found along the temperate southern coast of Australia, it is one of the ocean's most extraordinary masters of disguise. Its long body is covered with delicate, leaf-like appendages. These structures do not provide most of the animal's movement. Instead, they break apart its outline and allow it to resemble the vegetation around it. Small, transparent fins propel the sea dragon quietly through the water. Because these fins are almost invisible, the animal appears to drift without effort, like a loose branch carried by the current. Its movement is slow and controlled. Rather than swimming directly across open water, the sea dragon often changes direction gently, rocking with the waves and matching the motion of nearby kelp. This is camouflage through shape and behavior. The animal does not need to change color in an instant. Its body has evolved into a permanent disguise, suited to the underwater forests where it lives. Yellow, green, brown, and reddish markings blend with kelp, sponge, and algae. The leafy projections create false edges around the body, making it difficult to determine where the animal begins and the vegetation ends. Even the long snout resembles a narrow plant stem. The sea dragon spends much of its time searching for tiny crustaceans. It has no teeth and no powerful jaws. Instead, it approaches small shrimp-like animals slowly and draws them into its tubular mouth with a rapid movement. The feeding action is brief. Moments later, the sea dragon returns to its drifting posture and becomes part of the vegetation once again. Nearby lives a close relative. The weedy sea dragon has fewer leaf-like appendages, but its long body is decorated with vivid stripes, spots, and short projections. These markings may seem bright and noticeable when viewed alone. Among colorful algae, however, they break the body into irregular sections. Strong patterns do not always make an animal easier to see. When surrounded by the correct background, they can make its true shape harder to understand. The weedy sea dragon also moves with the current. It angles its body beside long kelp blades and uses small fins to make subtle corrections. A sudden, powerful movement would reveal it, so it travels with patience. Every turn is gentle. Every pause allows the surrounding vegetation to hide it again. Farther north, within tropical coral reefs, another group of fish uses a similar strategy. Ghost pipefish hover beside soft coral, sea fans, feather stars, and drifting algae. Some are long and narrow. Others have broad fins and irregular edges that resemble dead leaves. Their colors may be red, yellow, white, brown, or almost black, depending on the habitat around them. A robust ghost pipefish can look like a fragment of seagrass. An ornate ghost pipefish may disappear among the branching arms of a feather star. The fish often holds its body at an unusual angle, sometimes with the head pointing downward. This posture helps align the body with coral branches and plant stems. Like the sea dragons, ghost pipefish rely on small, almost invisible fin movements. The body seems to float rather than swim. Their disguise becomes especially effective when the current begins to move. Vegetation bends. Feather stars wave their arms. Loose leaves rise and fall. The pipefish copies this rhythm, allowing motion to hide motion. Within a seagrass meadow, ordinary pipefish use a simpler version of the same design. Their bodies are extremely narrow, and many are colored green, brown, or gold. By holding themselves vertically among the grass, they reduce the difference between animal and plant. Only the movement of the eyes or the vibration of a tiny fin reveals their presence. These fish cannot rely on speed. Their bodies are designed for precise movement rather than powerful escape. Camouflage gives them the time they need. A predator may pass close by without recognizing the long shape hidden beside a blade of grass. But the disguise also helps while feeding. Tiny crustaceans drifting through the vegetation may approach without sensing danger. The pipefish waits until the prey is close, then uses its narrow mouth to create a sudden suction. Once again, the movement is quick and almost invisible. Life among marine plants requires constant adjustment. A sea dragon may be perfectly hidden beside golden kelp, but clearly visible over pale sand. A red ghost pipefish disappears among crimson coral, yet stands out against green seagrass. These animals must choose their surroundings carefully. The habitat completes the disguise. Color and body shape alone are not enough. Position, movement, and background must work together. As sunlight passes through the kelp canopy, the entire forest changes. Bright patches move across the rocks. Dark shadows slide over the plants. Leaves twist and overlap in the current. Within this shifting landscape, the hidden fish move with the vegetation. A leafy sea dragon drifts past a kelp blade. A ghost pipefish turns beside a sea fan. A slender pipefish becomes a vertical line within the grass. For a moment, each animal becomes visible. Then the current moves again. The leaves close around them, the patterns merge, and the living shapes disappear back into the underwater forest. Along the steep walls of a tropical coral reef, enormous sea fans spread their branches into the current. Their delicate structures form a living forest of red, orange, pink, and violet. Thousands of tiny polyps open across the surface, capturing particles carried through the water. Hidden among these branches is one of the smallest vertebrates in the ocean. A pygmy seahorse may be shorter than a human fingernail. Its body is covered with rounded bumps that closely resemble the closed polyps of the coral around it. Its colors follow the same patterns as the sea fan, creating one of the most precise disguises found anywhere beneath the sea. At first, the coral appears to contain nothing unusual. Then a tiny eye turns. A curled tail tightens around one branch. The hidden shape slowly becomes recognizable. Pygmy seahorses do not simply rest beside these corals. Their entire lives are closely connected to them. The sea fan provides shelter from strong currents and protection from predators. It also offers a complex surface where tiny crustaceans and other food can be found. But the seahorse must remain almost invisible. It has little speed and no powerful defense. Its small fins can move the body only short distances, and its rigid shape prevents the rapid escape used by many other reef fish. Camouflage is its greatest protection. The bumps covering its body are known as tubercles. Their size, shape, and arrangement resemble the coral polyps surrounding the animal. Pale markings around the tubercles imitate the lighter edges of the host branches. Even the texture of the skin helps remove the smooth outline that would reveal a fish. Color completes the illusion. Some pygmy seahorses are deep red with pink bumps. Others are yellow, orange, lavender, or pale gray. These colors are closely associated with the sea fans on which they live. The match is so accurate that even experienced observers may search the coral for several minutes without finding the animal directly in front of them. The disguise is not created through the rapid color changes seen in octopuses and cuttlefish. Instead, it develops gradually as the young seahorse grows on its chosen host. Its appearance becomes closely suited to that particular coral environment. Once established, the animal rarely travels far. Moving onto a sea fan of a different color would make the disguise far less effective. So the pygmy seahorse remains within a small territory, often spending its entire adult life among the same network of branches. Its movements are careful. The tail remains wrapped securely around the coral, while the body leans into the current. A small dorsal fin beats rapidly, but because the fin is almost transparent, its movement is difficult to see. Tiny fins near the head help control direction and balance. The seahorse may release its grip, drift a few centimeters, and attach itself to another branch. Every journey is brief. In open water, the animal would become more visible and vulnerable. Among the coral, it can disappear again almost immediately. The eyes move independently, allowing the seahorse to watch different parts of the reef at the same time. One eye may follow drifting food, while the other searches for approaching danger. This wide awareness is essential for an animal that cannot flee quickly. When a tiny crustacean passes within reach, the seahorse slowly turns its head. It does not chase. Instead, it waits until the distance is small enough. Then the tubular snout opens suddenly, creating suction that pulls the prey into the mouth. The movement lasts only a fraction of a second. Almost immediately, the seahorse returns to stillness. Once again, it appears to be only another coral polyp. Several pygmy seahorses may share the same sea fan, yet they are rarely easy to find. A pair can remain only a few branches apart while appearing completely separate from one another. During courtship, however, they become more active. Two animals may release their tails and rise slightly above the coral. Their bodies move together in a slow and delicate display. For a brief time, the need to communicate becomes more important than remaining perfectly hidden. Then they return to the branches and vanish again. Like other seahorses, the male carries the developing young. The female transfers her eggs into a brood pouch on his body. Inside, the eggs receive protection as they develop. When the young are ready, the male releases them into the surrounding water. The newborn seahorses are extremely small. They must survive drifting currents and open water before eventually locating a suitable coral habitat. Only a few will reach adulthood. For those that do, finding the correct sea fan is a turning point. The coral becomes shelter, feeding ground, and permanent home. But life within this hidden world is delicate. Sea fans can be damaged by storms, changing water conditions, disease, and physical disturbance. Because pygmy seahorses depend so closely on a specific host, the loss of one coral colony may also mean the disappearance of the animals living within it. Their camouflage is extraordinarily effective, but it cannot protect them from changes to the entire habitat. As the current strengthens, the sea fan bends slowly into the blue water. Thousands of polyps move together. The branches sway. Particles drift past in the light. For a moment, the tiny seahorse is visible as it changes position. Its tail releases one branch. The transparent fins begin to move. It crosses a narrow opening and grips the coral again. Then the body aligns with the polyps. The colors merge. The outline disappears. What seemed to be a tiny fish becomes part of the sea fan once more. In this forest of coral, survival does not depend on becoming larger, faster, or stronger. It depends on perfecting the smallest details. A bump shaped like a polyp, a body colored like a branch, a movement gentle enough to escape attention. And with these adaptations, one of the ocean's smallest fish can remain hidden inside one of its most colorful landscapes. Across the reef, countless small creatures move beneath the larger animals. They crawl through coral branches, hide inside sponges, cling to sea fans, and disappear into cracks no fish could enter. At first, they may seem insignificant, but together, these tiny animals form one of the most active communities in the ocean. They are the crustaceans: shrimp, crabs, amphipods, squat lobsters, and many of their relatives fill almost every marine habitat. Their jointed legs and hard outer skeletons give them an insect-like appearance, yet they belong to a far older world beneath the sea. For many of them, survival depends on remaining unseen. A transparent shrimp rests on a pale anemone. Most of its body allows light to pass through. Only the eyes, digestive system, and a few colored markings remain visible. Against the moving tentacles, its outline almost disappears. The shrimp does not need to match every color around it. By reducing the amount of visible tissue, it becomes difficult to separate from the water itself. Its legs move constantly. Fine claws collect particles from the surface of the anemone, while long antennae test the current. Every movement is delicate. A sudden motion could attract the attention of a passing fish. Nearby, another shrimp uses a very different strategy. Bright red and white markings cover its body. Instead of hiding completely, it waits at a familiar cleaning station on the reef. Large fish approach slowly and open their mouths. The shrimp climbs across their scales, removing parasites, dead skin, and unwanted material. Its bold colors act as a signal. They announce that this tiny animal is not ordinary prey. It offers a service. The relationship benefits both animals. The fish receives cleaning, while the shrimp gains a reliable source of food. But even here, caution is essential. The shrimp remains close to coral branches where it can retreat instantly if danger appears. Not all crustaceans advertise their presence. A small squat lobster hides inside the folds of a barrel sponge. Its flattened body fits into narrow spaces, while red, orange, or purple markings resemble the colors of the sponge around it. Long claws extend from the entrance, collecting drifting food. The rest of the animal remains protected within the shadows. Only when the current changes does it move farther out. For a moment, its full shape becomes visible. Then it slips back into the sponge and disappears again. Porcelain crabs live beneath stones, among coral rubble, and inside the branches of anemones. Despite their name, they are not true crabs. Their bodies are broad and flattened, allowing them to occupy spaces that larger animals cannot reach. Instead of chasing food, they extend feather-like mouthparts into the current. Tiny particles become trapped on the delicate hairs and are drawn toward the mouth. The process is repeated again and again. To survive while feeding in the open, many porcelain crabs match the color and texture of their host. Some are pale like sand. Others carry red spots, purple patterns, or bands that blend with coral and sponge. Each disguise is suited to a particular corner of the reef. Among branching coral, tiny amphipods cling to algae and hydroids. Their bodies are curved and compressed from side to side. Some resemble small shrimp, while others are so unusual that they appear almost alien. Yet their shapes are perfectly adapted to life among narrow stems and delicate polyps. A few species cover themselves with fragments of algae. Others are transparent, green, brown, or patterned like the surfaces they inhabit. Because of their size, they live in a world of enormous textures. A single coral polyp becomes a shelter. A strand of algae becomes a forest. A sponge opening becomes a cave. For these animals, the reef is not one landscape. It is thousands of separate worlds layered together. Crabs are among the most familiar crustaceans, but their disguises can be extraordinary. A sponge crab carries a living piece of sponge over its back. Its rear legs hold the sponge securely as the crab moves across the seafloor. The soft covering hides the hard outline of the shell and may also make the animal less attractive to predators. As the crab grows, it may trim or replace the sponge. The disguise is not part of its body. It is chosen, shaped, and carried. Another crab goes even further. The decorator crab attaches fragments of algae, sponge, and hydroids to tiny hooked hairs across its shell. It selects materials from the environment and places them carefully onto its body. Over time, these living decorations continue to grow. The crab becomes a moving piece of the reef. When it enters a new habitat, it may change the materials it carries. Green algae are useful among seagrass. Red sponge works better on a colorful reef. The camouflage can be rebuilt to match each location. This is not rapid color change. It is disguise created through behavior. The crab's body provides the structure, but the surrounding habitat supplies the costume. Stillness completes the effect. When the crab stops moving, the attached organisms sway naturally in the current. A predator may see only algae or sponge. But once the animal begins to walk, the illusion becomes more difficult to maintain. Movement always carries risk. Across the reef, crustaceans have solved this problem in different ways. Some move only at night. Others remain beneath rocks during the day. Many travel slowly, pausing whenever a shadow passes overhead. Their long antennae detect vibrations before danger arrives. Sensitive hairs on their legs and shells respond to changes in the water. A fish does not need to be seen. Its movement can be felt. As daylight fades, the hidden community becomes more active. Small crabs leave their shelters. Shrimp emerge from coral crevices. Amphipods move across algae, and squat lobsters extend their claws farther into the current. The reef floor begins to crawl with life. Yet most of this activity remains unnoticed. Every crack contains movement. Every sponge hides delicate legs. Every coral branch may shelter an animal no larger than a grain of rice. These creatures may be small, but their role is immense. They recycle organic material, clean larger animals, filter the water, control algae, and provide food for countless fish. Much of the reef's daily work is carried out by bodies almost too small to see. Beneath the bright colors and larger forms of the ocean, another world continues in miniature. A world of transparent shells, careful claws, living disguises, and endless movement. Here, the smallest animals survive not through strength, but through precision. They hide inside the details of the reef, and in doing so, they become nearly invisible within one of the busiest ecosystems on Earth. Across the reef, a small crab moves slowly beneath a covering of algae, sponge, and delicate hydroids. At first, it appears to be nothing more than a fragment of the seabed carried by the current. Then, several thin legs emerge from beneath the living growth. This is the decorator crab. Unlike animals that depend only on the colors and patterns of their own bodies, decorator crabs build camouflage from the world around them. Their shells are covered with tiny hooked structures called setae. These act like natural fasteners, holding pieces of algae, sponge, coral debris, and other living organisms against the body. The disguise begins with careful selection. Using its claws, the crab searches the reef for suitable material. It may cut a small fragment of seaweed, hold it near its mouth, and prepare it before attaching it to the shell. Each piece is placed deliberately. Green algae may cover the legs. Soft sponge may be fixed across the back. Fine hydroids can be attached near the edges of the body, breaking apart the crab's hard outline. Slowly, the animal disappears beneath its collection. The process requires time and energy, but the result can be remarkably effective. When the crab remains still, the attached materials move naturally in the current. The algae bends. The hydroids sway. The sponge retains the same texture as the surrounding reef. A passing predator may see only another patch of living growth. The crab itself becomes almost impossible to recognize. This camouflage is flexible. A crab living among green seaweed may choose mostly green material. Another resting on a colorful sponge reef may carry red, orange, or yellow fragments. When the animal moves into a different environment, the old covering may no longer provide protection, so the disguise can be changed. Unwanted pieces are removed, and new material is collected from the surrounding habitat. The crab does not need to alter its skin. It rebuilds its appearance instead. Young decorator crabs are often especially active. Their smaller bodies are vulnerable to many predators, and even a thin covering can greatly improve their chances of survival. They spend long periods gathering and attaching material, sometimes covering nearly every visible part of the shell. As the crab grows, however, the hard outer skeleton becomes too small. Like other crustaceans, it must molt. The old shell splits, and the crab pulls itself free, leaving behind the decorated surface it worked so carefully to create. The new shell is soft and unprotected. For a short time, the animal is highly vulnerable. Once the shell hardens, the work begins again. Some crabs recover useful material from the old shell and transfer it to the new one. Others begin collecting a completely new covering. The disguise must be rebuilt throughout life. Not every decoration serves only to hide the crab. Some attached organisms may provide additional protection. Certain sponges and hydroids contain chemicals or stinging cells that make them unpleasant to predators. By carrying these organisms, the crab may become both difficult to see and less attractive to eat. The relationship can benefit the attached organisms as well. They are transported into currents, carrying fresh food and oxygen. Instead of remaining fixed to one rock, they travel across the reef on the crab's back. The crab becomes a moving habitat. Tiny organisms grow, feed, and sometimes reproduce upon its shell. What began as camouflage develops into a small living community. Other crabs use related strategies. A sponge crab carries a larger piece of sponge over its back, holding it in place with specially adapted rear legs. The crab may trim the sponge until it fits the shape of the shell. As the sponge continues to grow, it can form a natural covering that hides the crab from above. When danger approaches, the animal freezes. Its legs fold beneath the body. The sponge rests against the seafloor, and the crab disappears below it. The observer sees the covering, but not the animal carrying it. Decorator crabs must move carefully. Their long legs allow them to step across uneven coral rubble, but every movement can reveal the disguise. They often walk slowly, pausing between steps. When nearby algae sways to one side, the crab may move with it. When the current becomes still, the animal stops. Camouflage is most convincing when behavior matches appearance. Even the best covering cannot hide rapid or unnatural movement. At night, decorator crabs become more active. Under the protection of darkness, they leave resting places and search for food. Their claws collect algae, small animals, and organic material from the reef. Long antennae examine the water ahead, detecting vibrations and chemical signals. Although their bodies are hidden, they remain constantly aware of the world around them. A shadow passing overhead can cause immediate stillness. A sudden vibration sends the crab toward the nearest crevice. The living disguise reduces danger, but it does not remove it. Large fish can still discover the animal through movement, scent, or experience. Some predators learn to recognize the unusual shape of a decorated shell. Others may investigate anything that moves across the seabed. This creates a continuous contest. The crab improves its disguise. Predators improve their ability to see through it. No form of camouflage remains perfect forever. Across different oceans, decorator crabs use whatever materials are available. In tropical reefs, they may carry colorful sponge and delicate hydroids. In temperate waters, brown and green seaweed provide better concealment. On sandy bottoms, pale fragments and shell debris help soften the dark outline of the body. Each disguise reflects the habitat in which it was created. No two crabs are decorated in exactly the same way. Their appearance depends on personal choice, local materials, body size, and the animals growing nearby. The result is a form of camouflage that is partly inherited and partly constructed. The hooked setae are provided by evolution, but the final disguise is built through behavior. As sunlight moves across the reef, the decorated crab settles beside a cluster of sponge and algae. Its legs stop. The attached hydroids sway gently in the current. Colors, shapes, and textures merge with the surrounding growth. A moment earlier, the crab was clearly visible. Now, it has become another small piece of the reef. Hidden beneath a garden carried on its own back, it waits for darkness before moving again. Beyond the crowded reef, the water appears clear and almost empty. Sunlight passes through the blue without meeting coral, rock, or vegetation. In this open space, there are few places where a small animal can hide. Yet countless creatures drift here unseen. Their protection comes from one of the most extraordinary forms of camouflage in the ocean: transparency. A tiny glass shrimp floats between shafts of sunlight. Its shell, legs, and muscles allow much of the surrounding light to pass through. Against the open water, the body has almost no solid outline. Only its dark eyes, fine antennae, and a few internal structures reveal that an animal is present. For a creature only a few centimeters long, even this limited visibility can be dangerous. The eyes must absorb light in order to see, and this makes them difficult to conceal. Some transparent animals reduce the problem by having narrow eyes or reflective surfaces that match the brightness around them. Others position their bodies carefully, presenting the smallest possible shape to anything watching from below. The glass shrimp moves with gentle strokes of its swimming legs. Each motion is small and controlled. A rapid escape would attract attention, so the animal often drifts with the current, allowing the water to carry it through the blue. Its transparency does not make it completely invisible. When viewed from the correct angle, sunlight reflects from the outer shell and briefly reveals the entire body. Then the shrimp turns. The reflection disappears, and the animal fades into the water once more. Many young fish begin life in a similar form. After hatching, their bodies may be thin, delicate, and almost transparent. They drift as part of the plankton, far from the reefs and coastal habitats where they may eventually settle. At this stage, they are surrounded by danger. Jellyfish, larger fish, and countless other hunters search the water for small prey. A transparent body offers protection without adding weight or slowing movement. The young fish has little pigment and few reflective scales. Light passes through the muscles and fins, leaving only the eyes and faint internal tissues visible. As it grows, this disguise may change. Pigment spreads across the skin. Scales develop. The body becomes stronger and more recognizable. The invisible larva gradually becomes a silver juvenile, prepared for a different life. Nearby, a chain of salps drifts through the surface water. Each salp is a transparent, barrel-shaped animal. Some travel alone, while others form long colonies containing many connected individuals. Their bodies contract rhythmically, pushing water through internal filters. Tiny food particles are trapped as the water passes through. Although salps resemble jellyfish, they belong to a very different branch of animal life. Their simple, clear bodies are perfectly suited to the open ocean. There is little color to attract attention, and almost no shadow beneath them. A chain can extend for several meters, yet remain difficult to see until sunlight catches its surface. The colony moves slowly, rising and falling with the water. Around it, tiny fish sometimes seek temporary shelter. The transparent structure offers little physical protection, but its drifting shape can break the outline of a juvenile fish and make it more difficult for predators to identify. Comb jellies also float through this clear world. Their rounded bodies are made mostly of water. Along their sides, rows of microscopic structures beat in coordinated waves. These comb rows do not produce their own rainbow light. Instead, they divide the sunlight into shifting colors. Blue, green, gold, and violet travel across the transparent body as it turns. The display is beautiful, but delicate. From most angles, the animal remains almost invisible. Only the moving bands of color reveal its path. Some species use sticky cells to capture tiny prey, while others feed on different gelatinous animals. Their movement is slow, silent, and almost effortless. Deeper below, a glass squid hangs in the blue. Its mantle is transparent, but complete transparency creates a problem. The digestive organs cannot allow light to pass through as easily as the surrounding tissue. Dark internal structures would create a visible silhouette. To reduce this contrast, the squid holds its organs in a narrow vertical arrangement. Reflective tissues may also cover parts of the body, redirecting the faint light around them. Its eyes remain large. In dim water, large eyes gather more light and help detect movement at a distance, but they are also among the most visible parts of the animal. Some glass squid use small light-producing organs beneath the eyes, reducing the dark shadows that might reveal them from below. Transparency and light work together. Even smaller creatures drift nearby. Amphipods, larval crabs, and delicate shrimp move through the water like tiny fragments of glass. Their legs and antennae are so fine that they disappear against the shifting background. Some have bodies covered with reflective surfaces. Others contain very little pigment. Each species reduces visibility in a different way. For these animals, hiding does not mean matching a single background. The background is constantly changing. Above them is bright surface light. Below lies deep blue water. From the side, the ocean may be empty and uniform. A transparent body remains useful from almost every direction. But the strategy has limits. As the sun moves lower, the angle of light changes. Transparent tissue can suddenly reflect like a mirror. Internal organs may become visible. A passing predator may notice a dark eye suspended in the water and investigate. The smallest creatures must remain alert. Some escape with rapid flicks of the tail. Others stop moving and sink slowly. A few release faint clouds of material or hide among larger gelatinous animals. There is no permanent safety in the open ocean. As evening approaches, the blue water darkens. The transparent animals become even more difficult to see. A glass shrimp fades into the twilight. A salp chain becomes a faint outline. The eyes of a larval fish remain visible for a moment, then disappear as it turns away. What first appeared to be empty water is filled with drifting life. Tiny bodies feed, grow, and travel across enormous distances. They have no caves, coral branches, or sand beneath which to hide. Instead, they carry almost nothing for the eye to recognize. In a world without shelter, survival belongs to those that can become part of the water itself. And throughout the open sea, these delicate ghosts continue their silent journey, hidden within the light that passes through them. In the shallow waters of the reef, survival does not always depend on becoming invisible. Sometimes, an animal survives by appearing to be something else. A harmless fish may imitate a dangerous species. A predator may copy the behavior of an animal trusted by its prey. An octopus may arrange its flexible body into shapes that cause an approaching hunter to hesitate. This is mimicry. Unlike simple camouflage, mimicry creates a false identity. The animal does not truly transform. Its anatomy remains unchanged. But through color, posture, movement, and behavior, it produces an impression powerful enough to deceive another creature. Across an open sandy plain, a mimic octopus emerges from its burrow. There are few rocks, corals, or plants nearby. The pale seabed offers little protection, and the octopus would be easy to recognize if it moved in its ordinary form. Instead, it changes the way it carries its body. Dark and pale bands spread across the skin. Several arms are drawn together while others trail behind. The animal flattens close to the sand and moves with slow, wave-like motions. From a distance, the shape may suggest a flatfish. The octopus has not become another species. Its arms, eyes, and mantle remain the same. But a predator searching quickly may not have time to examine every detail. It sees a striped shape moving close to the bottom. For one uncertain moment, the octopus is no longer recognized as familiar prey. That moment may be enough to escape. When a different threat approaches, the posture changes again. The octopus may raise several arms into the water, and allow them to move with the current. The remaining arms are hidden beneath the body. The result can resemble the spreading form of a venomous lionfish. In another situation, the animal may extend long, narrow arms along the seabed, producing the general appearance of a sea snake. Each display uses the same body. Only its arrangement changes. The mimic octopus does not select these postures at random. Its response appears to depend on the type of danger it faces and the environment around it. This suggests a remarkable ability to observe, decide, and adapt. Nearby, the Wunderpuss octopus uses bold stripes and careful movement in a similar way. Its markings remain more consistent, but its flexible arms can alter the apparent shape of the body. Against pale sand, the dark pattern breaks the animal into separate fragments. A predator may see stripes, shadows, and moving lines without immediately recognizing an octopus. Strong patterns can sometimes hide an animal more effectively than dull colors. They overwhelm the eye with false boundaries. Fish also use mimicry. On a busy coral reef, cleaner wrasses provide an important service. Large fish visit special cleaning stations, where the small wrasses remove parasites and damaged tissue from their skin, mouths, and gills. The cleaners are recognized by their distinctive colors and movements. A large predator may allow one to approach its face without attacking. This trust creates an opportunity. The false cleaner fish resembles a genuine cleaner wrasse in both shape and pattern. It approaches larger fish with similar movements, appearing to offer the same harmless service. But instead of removing parasites, it quickly bites a small piece of scale or skin and escapes. The deception lasts only a moment. After several attacks, local fish may become more cautious. This can make life difficult for genuine cleaners as well. Mimicry creates a constant contest between trust and suspicion. Another hunter uses imitation to approach prey without appearing dangerous. A trumpetfish has a long, narrow body that can be difficult to conceal in open water. It sometimes swims closely beside a larger, harmless fish, aligning its body with the companion's outline. From the opposite side, smaller fish may notice only the familiar shape of the larger animal. The trumpetfish uses this moving cover to reduce the visible distance between itself and its prey. This behavior is often called shadowing. The larger fish may receive little benefit, yet its body becomes part of the predator's disguise. Some trumpetfish also hang vertically beside sea fans or branching coral. Their narrow shape resembles a long piece of reef structure. Color, posture, and patience work together. Juvenile fish may rely on deception for protection. Young sweetlips move with exaggerated twisting motions, their bodies covered with bold patches of dark and light color. Their unusual swimming may resemble toxic or unpleasant flatworms. The resemblance is not exact, but it can make a predator hesitate before attacking. As the fish grows, its body shape, coloration, and behavior change. The juvenile disguise is no longer needed in the same form. Other young fish imitate drifting leaves. They hold their bodies at an angle and allow the current to carry them through seagrass or mangrove water. A predator may see only plant debris moving naturally with the waves. The fish occasionally makes a small correction with its fins, then becomes still again. Successful mimicry depends on performance. A leaf that swims strongly against the current would immediately appear suspicious. A false cleaner fish must approach with the confidence of a real cleaner. A mimic octopus must coordinate color, posture, and movement at the same time. The illusion survives only while every detail supports it. No deception is perfect. An experienced predator may recognize the hidden animal. A potential victim may learn to avoid an imitation. A change in viewing angle can reveal the true shape beneath the display. For this reason, mimicry continues to evolve. The better the imitator becomes, the more carefully other animals must observe. The more skilled the observer becomes, the more convincing the imitation must be. This is an evolutionary contest of recognition and deception. As afternoon light moves across the reef, false identities appear everywhere. An octopus becomes a confusing striped shape over the sand. A harmless juvenile resembles something dangerous. A predator approaches under the appearance of a trusted cleaner. A slender fish hides beside another animal's body. Nothing has physically transformed, yet perception has changed. In the ocean, an animal does not always need to be invisible. Sometimes, survival depends on being seen clearly, but recognized as the wrong thing. Across the tropical reef, coral grows into an endless variety of shapes. Some colonies rise like branches, others spread across the rocks in broad plates, rounded domes, or soft waving fans. Their surfaces are covered with thousands of tiny polyps, creating patterns of bumps, folds, openings, and shadows. For many animals, coral provides shelter. For others, it provides a disguise. A small goby rests on the surface of a branching coral colony. Its body carries the same pale colors and fine markings as the coral beneath it. Thin stripes break apart its outline, while translucent fins remain almost invisible against the water. The fish does not hide inside a hole. It remains exposed on the outer branches. Yet its pattern is so closely matched to the coral that passing predators may fail to recognize it. Only the quick movement of its eyes reveals its position. When danger approaches, the goby moves deeper between the branches. The retreat is short. Once the threat has passed, it returns to the open surface, where currents bring tiny drifting food. The coral is both feeding ground and protection. Nearby, a small crab clings to a sea fan. Its narrow body and long legs follow the shape of the coral branches. Red, orange, and white markings copy the patterns surrounding it. The crab positions itself carefully, keeping its limbs aligned with the structure beneath it. A leg extending into open water would create an unfamiliar line and reveal the disguise. So every movement is controlled. It steps only a short distance, then becomes still again. Some coral crabs live almost their entire lives within a single colony. The dense branches protect them from larger fish, while mucus and trapped particles provide food. In return, certain crabs may help defend the coral from small predators or remove material from its surface. Their camouflage is part of a close relationship with the habitat. The better they match the coral, the more safely they can remain among its branches. Tiny shrimp use the same environment in a different way. A transparent coral shrimp rests beside the open polyps of a soft coral. Most of its body allows light to pass through, but colored spots across the shell resemble the coral beneath it. The transparent areas reduce the visible shape. The colored areas create a connection with the background. Together, they form a disguise more effective than either strategy alone. Its long antennae remain difficult to conceal. They extend far beyond the body, moving gently through the water. To avoid attracting attention, the shrimp often positions them along coral branches, where their thin lines resemble natural structures. Movement must remain slow. A sudden flick would reveal the animal immediately. Among the folded surfaces of a sponge, a small scorpion fish waits without moving. Its skin has the same rough texture and orange color as the living sponge surrounding it. Irregular spots resemble openings across the sponge surface. Small projections break apart the outline of the head and fins. The fish appears to be another section of reef growth. Unlike the goby or shrimp, this animal is not hiding only from predators. It is also hiding from prey. Small fish and crustaceans move close to the sponge, searching for food among its openings. The scorpion fish remains still until one approaches within reach. Its success depends on the prey continuing to see coral, sponge, and shadow, rather than the body of a hunter. A frogfish uses an even more complete imitation. Its rounded body can resemble a sponge, so closely that algae and small organisms may begin growing across its skin. The fins are modified for walking slowly over the reef. Instead of swimming in open water, the frogfish places these fins against the surface and takes short, careful steps. Above its mouth is a narrow, natural lure. The tip may resemble a worm, shrimp, or tiny fish. While the body remains hidden as part of the reef, the lure becomes the only visible movement. This creates a powerful deception. An approaching fish notices what appears to be food. It does not recognize the larger shape beneath it. The coral reef is filled with these false appearances. A nudibranch may carry branching structures across its back that resemble soft coral or hydroids. A ghost pipefish can vanish among the arms of a feather star. Tiny squat lobsters hide within coral folds, their spots and stripes matching the host. Even some sea slugs feed on one particular coral or sponge and slowly take on colors similar to their food. But resemblance does not need to be exact. The reef is visually complex. Light flickers across the surface. Coral polyps open and close. Fish shadows move across the rocks. Particles fill the water. Within this confusion, an animal only needs to hide its most recognizable features: the round shape of an eye, the straight edge of a fin, the shadow beneath the body, the regular rhythm of breathing. Many coral mimics are covered with broken patterns that interrupt these clues. Spots may cross the eye. Lines may continue from the body onto the fins. Uneven skin creates false edges. When the animal remains still, the observer sees texture rather than anatomy. But every disguise depends on the correct background. A red crab hidden on a crimson sea fan would become obvious against white sand. A yellow goby matched to golden coral would stand out among dark rocks. These animals cannot carry their camouflage everywhere. They must remain close to the habitat that completes their appearance. This creates both protection and dependence. If the coral is damaged, the animals lose more than shelter. They lose the background that makes them difficult to see. As sunlight shifts across the reef, the hidden community begins to emerge. A shrimp moves between two polyps. A crab crosses a narrow coral branch. The eye of a scorpionfish turns toward the water above. For a moment, each animal becomes visible. Then movement stops. Colors merge. Edges disappear. The reef returns to stillness. What appears to be coral is sometimes a fish. What looks like sponge may be a predator. And among the smallest branches, an entire community survives by convincing the world that it is something else. As the sun disappears beyond the horizon, the coral reef enters another world. The brilliant colors of daylight slowly fade. Blue water deepens into violet, and long shadows spread across the seafloor. For a brief moment, the reef becomes quiet. Day-active fish search for narrow crevices. Parrotfish settle beneath coral ledges. Small wrasses disappear into sand, while schools of silverfish move toward safer resting places. Then darkness arrives, and a hidden community begins to emerge. At night, camouflage changes. Colors that were vivid beneath the sun become muted shades of gray, blue, and black. Red light disappears quickly underwater, causing many red-colored animals to appear almost invisible in the darkness. A bright crimson shrimp during the day may become a shadow at night. A red crab crossing the reef floor can vanish against dark coral and sponge. Here, color is shaped by the light available to reveal it. A reef octopus moves slowly from its shelter. During daylight, it remained hidden deep inside a rocky crevice. Now it travels across the exposed reef, searching for crabs, shrimp, and small animals concealed among the coral. Its skin changes with every surface. Over pale sand, the body becomes smooth and light. Across dark rock, deeper brown and gray patterns spread along the mantle and arms. Beside rough coral, flexible projections rise from the skin, breaking apart its soft outline. Even in darkness, camouflage remains essential. Many night hunters possess sensitive eyes. They can detect movement and contrast in light, too faint for humans to see. The octopus must remain hidden not only from its prey, but also from larger predators patrolling the reef. Nearby, a flounder lies flat on the sand. Its body is covered with fine spots and broken markings that resemble ripples, shells, and shadow. Only its raised eyes move. As the moonlight shifts across the seabed, the fish slowly adjusts its pattern. Then, with a gentle movement of its fins, it draws a thin layer of sand over its back. The outline disappears. A few meters away, a stargazer waits beneath the surface. Almost its entire body is buried. Its eyes and upward-facing mouth remain exposed, forming a strange shape within the sand. It does not search actively for food. It waits for movement above. In the darkness, stillness becomes even more powerful. A small fish may detect the stargazer only when it is already too close. Along the reef wall, a scorpionfish rests beside red sponge and dark algae. Its rough skin is covered with folds and small projections. These structures create false shadows, making the body resemble the uneven surface beneath it. The eyes are partly hidden by markings. The fins remain folded. Breathing is slow. Nothing about the animal clearly announces that it is a predator. Only when it changes position does the hidden shape become visible. Then it settles again, and the reef seems to absorb it. Stonefish use an even more complete form of stillness. Sand and debris gather naturally across their bodies. Algae and small organisms may grow on the skin, strengthening the illusion of an old rock resting on the seafloor. At night, their outlines become even more difficult to recognize. Small fish pass overhead, guided by weak moonlight and the faint glow of the surface. The stonefish waits below them. Among the branches of a sea fan, an ornate ghost pipefish hangs with its head angled downward. Its fins are broad and irregular, matching the arms of a nearby feather star. Dark red and pale markings divide its body into fragments. The current moves the feather star. The pipefish moves with it. In the low light, shape and motion become more important than exact color. The animal survives by matching the rhythm of the living structure around it. Many crustaceans also leave their shelters after sunset. Transparent shrimp climb onto coral branches. Hermit crabs cross the sand. Decorator crabs move beneath coverings of sponge and algae. During the day, their slow movements could attract hungry fish. At night, darkness gives them greater freedom, yet they remain cautious. Long antennae test the water for vibrations. A sudden pressure change can reveal the approach of a predator before it becomes visible. When danger passes nearby, movement stops immediately. The animal becomes part of the reef once more. Inside narrow coral openings, moray eels begin to emerge. Their patterned skin blends with rock, shadow, and encrusting growth. Only the head may remain visible outside the shelter. The mouth opens and closes slowly, moving water across the gills. This motion may appear threatening, but it is part of ordinary breathing. The eel waits, concealed by darkness and the broken patterns of its skin. Above the reef, squirrelfish and cardinalfish gather beneath ledges. Their large eyes are adapted to low light, allowing them to navigate when the bright colors of the reef have disappeared. Red bodies become dark in the blue night water. During daylight, they hide in caves. After sunset, their coloration becomes an effective disguise as they move into the open. Farther along the seabed, a wobbegong shark rests beneath coral shadows. Its flattened body is marked with complex patterns resembling sand, stone, and algae. Branching structures around the mouth disrupt the shape of the head. The shark appears less like a large animal and more like part of the reef floor. It conserves energy by remaining still, relying on concealment rather than speed. The night reef is filled with eyes. Some reflect the faintest light. Others remain hidden behind stripes, spots, or folds of skin. Every animal is watching. Predators search for movement. Prey search for shadows that move against the current. In darkness, even a small mistake can reveal a hidden body. A fin moving too quickly, An eye turning at the wrong moment. A silhouette crossing pale sand. Camouflage is never absolute. It is a temporary advantage in a world where every creature is learning how to detect another. As the night deepens, the reef becomes more active. Squid pass above the coral, their bodies shifting between pale silver and dark brown. Cuttlefish hover over sand, using subtle patterns to match the moonlit bottom. Crabs search through rubble, and shrimp gather food from the surfaces of coral. What appeared silent and empty after sunset is now crowded with movement, yet much of this life remains concealed. Darkness does not hide everything equally. Instead, it changes the rules. Red becomes black. Bright markings become broken shadows. Stillness becomes more convincing, and animals that were hidden during the day step into a new landscape shaped by moonlight. Before dawn, the activity begins to slow. Night hunters return to caves and crevices. Crustaceans disappear beneath stones. The octopus moves back toward its den. A faint blue glow returns to the water above. As the first sunlight reaches the reef, colors begin to emerge again. The hidden animals must change with them. One world is ending. Another is about to begin. And throughout the coral reef, camouflage continues without rest, transforming with every change between darkness and light. In the darkness beneath the reef, the first sign of a hidden animal is often not its body. It is an eye. A small circle turns beneath the sand. A dark pupil opens between coral branches. A faint reflection appears inside a rocky crevice, then disappears before the animal itself can be recognized. Eyes are essential for survival. They detect movement, measure distance, locate food, and reveal the approach of danger. But they also create a problem. Even when the rest of the body is perfectly camouflaged, a smooth, round eye can expose the presence of something alive. Across the ocean, hidden animals have evolved remarkable ways to conceal their gaze. On a sandy seabed, a flounder lies almost completely flat. Both eyes rise from the upper side of its head, allowing it to watch the water while the body remains pressed against the bottom. Its skin matches the pale sand and broken shell fragments beneath it. Then the fish begins to bury itself. Its fins move gently, lifting sediment that falls across its back. Soon, only the eyes remain visible. They stand like two small watchtowers above the surface. Each can move independently, scanning a different part of the water. One follows a distant shadow. The other watches a small crustacean moving nearby. The flounder remains still. Its body has disappeared, but its vision remains active. A stargazer hides even deeper. Almost its entire body lies beneath the sand, with only its upward-facing eyes and mouth exposed. The unusual position of the eyes allows the fish to watch the world directly above it. From the side, there is almost nothing to see. A slight depression, a change in texture, two shapes that resemble dark stones. The stargazer waits patiently, relying on the seabed to conceal everything except the organs it needs. Movement must be minimal. A sudden turn of the head would disturb the sand. Instead, only the eyes shift. The predator observes, without revealing the body beneath them. Nearby, a crocodile fish rests among coral rubble. Its broad head is covered with mottled markings that resemble sand, rock, and broken sponge. But its most unusual camouflage lies above the eyes. Delicate, lace-like structures extend across them, dividing the dark pupil into smaller shapes. Without these coverings, the smooth eye would stand out against the rough surface of the head. The branching pattern removes that familiar outline. What should look like an eye becomes another patch of reef texture. Scorpionfish use color and shadow in a similar way. Dark stripes often pass directly across the eyes, connecting them with markings on the face. The line prevents the observer from seeing the eye as a separate round object. Skin flaps and small projections create additional shadows around the head. Even when the fish looks directly toward the camera, its gaze remains difficult to locate. Only a slow rotation of the pupil reveals where the animal is watching. For an ambush predator, concealed eyes provide a major advantage. The fish can follow approaching prey without moving its whole body. A small animal may notice a shifting fin or an opening mouth, but the movement of a hidden eye is much harder to detect. The hunter can wait until the final moment. Inside a reef crevice, a moray eel watches from the darkness. Only its head extends beyond the rock. Patterns of brown, yellow, and black break apart the long shape of its face. The eyes are small compared with the head, reducing their visibility. The mouth opens and closes slowly as water moves across the gills. This steady breathing is natural, but the rest of the animal remains hidden. From outside the crevice, shadow conceals the body. The eel sees the reef without fully entering it. Other animals depend on unusually large eyes. Squirrelfish and cardinalfish become active when daylight fades. Their eyes gather the weak light available beneath ledges and within caves. During the day, these large reflective surfaces could make them easy to notice, so the fish remain in shadowed shelters. At night, they move into open water. Their red bodies appear dark in the blue environment, while their eyes detect movement that many daylight species can no longer see. A feature that would be dangerous in bright water becomes an advantage after sunset. Squid and cuttlefish possess some of the most advanced eyes in the ocean. A cuttlefish hovers over the sand, its W-shaped pupils surveying a wide area. The animal's body may match the seabed perfectly, yet the eyes must remain uncovered. To reduce their visibility, dark and pale markings spread around them. The pattern connects the eyes with the rest of the head, making their exact position harder to identify. The pupils can detect contrast, movement, and polarized light. Even when the reef appears dim and colorless, the cuttlefish continues to read details hidden from human vision. An octopus takes concealment further. It can change the skin surrounding each eye, raising projections that resemble rough coral or algae. The eye may sink slightly beneath folds of textured skin. Dark markings extend across the head, while the pupil remains narrow and horizontal. When the octopus presses itself against rock, the eye becomes part of a larger pattern. For a moment, it disappears completely. Then the pupil turns. The stone seems to look back. Not every hidden eye belongs to a predator. A tiny seahorse clings to a coral branch, watching for both food and danger. Its eyes move independently. This allows the animal to search in two directions without turning its body and breaking the camouflage. A decorator crab peers through algae and sponge attached to its shell. A transparent shrimp remains almost invisible except for two dark eyes. A buried ray keeps its gaze above the sand while the broad body stays concealed below. For all these animals, the eyes must remain exposed. Vision is too important to surrender. The challenge is to reveal only what is necessary. Patterns can cross the pupil. Skin can grow around it. The body can be buried beneath sediment. The animal can remain inside shadow while its eyes monitor the brighter world outside. Every solution balances concealment with awareness. As darkness deepens, the reef becomes filled with silent observers. A flounder watches from beneath the sand. A scorpionfish follows movement above the coral. An octopus studies the rocks from inside its changing skin. A moray waits behind the entrance of its den. Most of their bodies remain invisible, but their eyes continue to search. In the ocean, seeing first can mean feeding. It can mean escaping. It can mean surviving another night. And sometimes, the only clue that a hidden animal is present is a single eye turning slowly within the darkness. among the coral and sponge gardens of the reef. One of the ocean's strangest hunters waits without moving. Its body is rounded and uneven. Its fins resemble small limbs resting against the seafloor. Its skin may be yellow, orange, red, brown, black, or covered with spots and branching growths. At first, it looks nothing like a fish. This is the frogfish. Rather than swimming constantly through open water, frogfish spend much of their lives sitting among sponge, coral, algae, and rock. Their camouflage is so complete that even nearby fish may fail to recognize them. A yellow frogfish settles against a golden sponge. Dark openings across the sponge are repeated by spots on the animal's skin. Small bumps and folds break apart the smooth surface of its body. The fins remain spread against the reef, supporting the fish in an almost upright position. Only the eyes move. Everything about the animal encourages the observer to see sponge rather than predator. But camouflage is only the first part of the deception. Above the frogfish's mouth is a modified spine known as the elysium. At its tip is a small structure called the esca. This is the lure. In some species, it resembles a worm. In others, it may look like a shrimp, a tiny fish, or a drifting piece of food. The frogfish can move the lure independently, bending and circling it above the head. The body remains hidden while the false prey becomes the center of attention. A small fish passes over the reef. It notices a delicate shape moving beside the sponge. The lure rises, pauses, and moves again. The fish turns toward it. From its perspective, the scene appears safe. There is no obvious hunter, only a piece of food moving within reach. The frogfish makes tiny adjustments. Its fins press against the reef. The head turns by only a few degrees. The lure moves closer to the mouth. The approaching fish follows. Every movement is controlled. If the lure moves too quickly, the prey may become suspicious. If the frogfish shifts its body too early, the disguise will fail. Success depends on patience. The prey must enter a very small area directly in front of the predator. Then, without warning, the frogfish opens its mouth. The mouth expands with extraordinary speed, creating powerful suction that draws water inward. The action lasts only a fraction of a second. There is no pursuit through the reef, no long chase. The frogfish remains in place, closes its mouth, and slowly returns the lure to its original position. Once again, it appears to be part of the sponge. This hunting method allows the animal to conserve energy. Frogfish are not built for continuous fast swimming. Their bodies are compact, and their fins are adapted for careful movement across the bottom. When they need to change position, they often walk. Modified pectoral fins press against the reef like small hands. The fish takes one slow step, then another. Each movement is deliberate. A long crossing over open sand would expose the animal, so it usually travels only as far as necessary. When a suitable sponge or coral head is found, the frogfish settles again. Its skin may gradually change over time. This color adjustment is much slower than the rapid transformations of octopuses and cuttlefish. A frogfish may require days or weeks to develop a closer match with a new background. Because of this, choosing the correct resting place is essential. An orange individual is safest among orange sponge. A dark frogfish disappears more effectively in shaded coral and black sponge. A patterned animal may hide among shell fragments and encrusting growth. The habitat completes the disguise. Some frogfish are covered with long, hair-like structures. These filaments move gently in the current, resembling algae or fine growth across the reef. A hairy frogfish can appear almost shapeless. The fins, body, and face are hidden beneath a moving fringe. Only the lure behaves differently. It rises above the camouflage and performs its careful imitation. Other species have smoother bodies, with bold spots or patches. Juvenile frogfish can be especially colorful. Their markings may resemble toxic sea slugs, flatworms, or small pieces of drifting debris. At this stage of life, they are vulnerable to many larger predators. An unusual appearance may discourage attack or make their true identity difficult to understand. As they grow, The disguise changes with their habitat. The lure also varies between species. A worm-like esca may be useful near sand and rubble. A shrimp-shaped lure is effective among coral, where small crustaceans are common. Some lures contain fine branches or moving filaments that increase the illusion of life. The design is closely connected to the prey available in each environment. This is aggressive mimicry. The predator does not simply hide. It creates a false signal designed to attract another animal. The prey's own feeding instinct becomes part of the trap. Yet the deception is not always successful. Some fish approach and then turn away. A sudden shadow may expose the frogfish. The lure may move in a way that appears unnatural. Experienced prey may recognize the danger before entering striking distance. When this happens, the frogfish does not chase. It lowers the lure and waits. Another opportunity may arrive later. Hours can pass between successful attacks. Patience is as important as camouflage. The frogfish must also avoid becoming prey itself. Large reef fish may discover its outline. A predator approaching from the wrong angle may see the eyes, fins, or breathing movement. When threatened, the frogfish can swim using rapid movements of the tail. It may also force water through openings behind the fins, producing a short jet that helps it escape. But these movements are usually brief. Its safest defense is to remain unrecognized. As the current moves across the reef, the sponge bends only slightly. The frogfish remains beside it. Fine particles settle on its skin. Small animals pass across the coral nearby. The lure begins to move again. Slowly, it rises above the head. A delicate shape twists in the water like a living worm. Another fish notices. It changes direction and approaches. The frogfish does not move. The false prey continues its dance. Beneath it, the hidden mouth waits. In this quiet corner of the reef, the hunter has turned its own body into a trap. Its skin becomes sponge. Its fins become part of the rock. Its lure becomes food. And the only thing that remains real is the sudden moment when the disguise comes alive. As daylight fades above the open ocean, the world below enters a zone of permanent twilight. Only a small fraction of sunlight reaches these depths. Blue light descends farther than every other color, becoming weaker with each passing meter. From above, animals appear as dark shapes against the remaining glow. From below, even a narrow silhouette can reveal life moving through the water. Here, darkness alone is not enough to hide. Some animals must create light of their own. A silver hatchetfish hangs almost motionless in the blue. Its body is thin and flattened from side to side. Mirror-like scales reflect the surrounding water, making the fish difficult to see when viewed horizontally. But from below, its body could still form a dark shadow against the faint light above. Along its underside are rows of tiny organs called photophores. These organs produce a soft blue-green glow. The light is not bright enough to illuminate the ocean around the fish. Instead, it is carefully matched to the brightness and color of the water above. The shadow disappears. This is counter-illumination. Rather than hiding inside darkness, the animal fills in its own silhouette with light. When a brighter shaft of sunlight reaches the depths, the photophores become slightly stronger. When the surrounding water darkens, their glow fades. The fish must remain balanced between being too dark and too bright. Either mistake could reveal it. Nearby, lanternfish use a similar strategy. Small light organs form patterns along their bellies and sides. Each species carries a different arrangement, like a quiet signature written in light. Some photophores help hide the animal from predators below. Others may allow lanternfish to recognize members of their own species in the darkness. Light becomes both camouflage and communication. As evening approaches, vast numbers of lanternfish begin rising toward the surface. During the day, they remain in deeper water where darkness offers protection. At night, they travel upward to feed on plankton. This daily movement is one of the largest migrations on Earth. Millions of small animals rise through the water column, then return to the depths before daylight exposes them. Their faint lights move with them. From a distance, the darkness appears filled with scattered blue-green points. But this is not a bright underwater sky. Each glow is small, controlled, and visible only from certain angles. A firefly squid moves through the dim water. Tiny photophores cover parts of its arms, head, and mantle. The squid can control these lights, producing brief patterns that may help with camouflage, courtship, or communication. When viewed from below, its glowing underside blends with the weak light filtering down from the surface. When the animal turns, the pattern changes. The body becomes visible for a moment, then fades again. Other squid combine light with transparency. A glass squid allows much of the surrounding illumination to pass through its body, but its eyes and digestive organs cannot become completely clear. Reflective tissues surround these darker structures, reducing the contrast that would expose them. Some species also carry light organs beneath their eyes. These help soften the dark shadow created by the large organs needed for vision. Every visible feature must be concealed. Even an eye can become dangerous in the twilight. Closer to the seafloor, a bobtail squid rests above pale sand. Symbiotic bacteria live inside a specialized light organ within its body. The bacteria produce a gentle glow, while the squid controls how much of that light escapes. As moonlight passes through the shallow water, the animal adjusts its brightness to match it. The light beneath its body removes the shadow that would otherwise appear on the sand. A small predator looking upward sees no dark silhouette. Another looking across the seabed sees no obvious shadow below. The squid carries a living source of camouflage inside its body. In return, the bacteria receive shelter and nutrients. Each partner depends on the other. Some sharks also use counter-illumination. A small cookie-cutter shark moves through deep tropical water. Its underside is covered with photophores that produce a faint green glow. From below, this light helps the body blend with the surface. But a dark band near the head remains unlit. The contrast may create the appearance of a smaller animal. The shark's camouflage can become part of a deeper deception. In the twilight zone, visibility is shaped by distance. Red colors disappear because red sunlight cannot reach these depths. A red animal may appear black. Silver surfaces reflect the surrounding blue. Transparent bodies reduce shadows. Ultra-dark skin absorbs almost every remaining trace of light. Bioluminescence adds another possibility. Animals can control not only how they reflect the world, but how they are seen within it. Yet producing light carries risk. A bright flash can attract attention from far away. For this reason, many deep-water creatures use light only briefly. A squid may release a glowing cloud when threatened, creating a false target while it escapes into darkness. A comb jelly may send blue-green pulses across its body after being disturbed. Small crustaceans can release luminous material into the water, leaving a predator surrounded by light while the animal itself disappears. In these moments, light is no longer camouflage. It becomes confusion. Some predators use bioluminescence to hunt. A dragonfish can produce faint red light from an organ beneath its eye. Most deep-sea animals cannot see red wavelengths. The dragonfish carries a private light, allowing it to search the darkness without revealing itself to much of its prey. The beam is subtle. It does not flood the water. It illuminates only a small area in front of the hunter. Elsewhere, an anglerfish carries a glowing lure above its mouth. The rest of its body remains dark and almost invisible. Only the small point of light moves. In a world where food is rare, another animal may approach the glow. The light suggests prey. The hidden body beneath it remains unseen. Once again, an animal's own senses are used against it. As the last daylight disappears from above, the ocean becomes almost completely dark. Silver fish lose their reflections. Transparent animals become faint outlines. Photophores appear along bellies, eyes, and fins. Each glow has been shaped by survival. Some erase shadows. Some identify a mate. Some confuse a hunter. Others attract prey. In the deep ocean, light is never wasted. It is measured, directed, and controlled. A lanternfish rises through the darkness. A glass squid fades beside it. Far below, a small shark adjusts the glow beneath its body. For a moment, each animal becomes visible. Then the brightness matches the water around it. The outline disappears. And in a world where even darkness can reveal a shape, life survives by creating just enough light to vanish. Far below the reach of sunlight, the ocean becomes a world of darkness. The water is cold. The pressure is immense. Food is scarce, and the seafloor may lie thousands of meters below. To human eyes, this region appears empty. But within the black water, strange shapes drift through the darkness. Some are transparent. Some reflect the faintest trace of blue light. Others possess skin so dark that almost nothing returns from its surface. These are the ghosts of the deep sea. A glass squid hangs quietly in the water. Its mantle is almost completely transparent, allowing light to pass through the soft tissue. Only the eyes and a few internal organs remain visible. Complete transparency is impossible. An animal must still see, breathe, digest food, and control its movement. Each necessary structure creates a shadow. The squid reduces this problem by keeping darker organs narrow and carefully arranged. Reflective tissues surround them, redirecting the little light that remains. From most angles, the body fades into the black water. The squid does not need to match a rock, plant, or sandy bottom. Its habitat has no fixed background. It must disappear against empty space. Nearby, a transparent amphipod drifts among falling particles. Its body is small and delicate, with fine legs and long sensory structures. Only its eyes are dark. When it turns, a faint edge of blue light passes across its clear shell. For a moment, the animal is visible. Then the angle changes, and it disappears again. The deep ocean is filled with marine snow. Tiny pieces of organic material fall continuously from the upper layers. Fragments of plankton, mucus, waste, and dead organisms descend slowly through the water. For deep-sea animals, this falling material is an important source of food. It also creates a constantly moving background. Transparent creatures drift among the particles, becoming difficult to distinguish from the debris around them. A ribbon-like larval eel moves through the darkness. Its body is flat, clear, and shaped like a narrow leaf. These young eels, known as leptocephali, can travel great distances before transforming into their adult form. Their transparent bodies contain very little dense tissue, This makes them light and difficult to see. A slow wave passes from head to tail. The animal moves forward without disturbing much water. It appears less like a fish and more like a thin piece of living glass. Deeper still, a barrel-eye fish waits beneath its transparent head shield. Inside the clear dome are two tubular eyes, usually directed upward. They search for the faint silhouettes of animals moving above. When food appears in front of the fish, the eyes can rotate forward. The clear shield protects these delicate organs, while allowing them to gather the weakest available light. The barrel-eye's strange appearance is not designed for display. Every feature is shaped by darkness. Large eyes collect light. A stable hovering posture saves energy. The upward gaze watches the zone where prey is most likely to appear. In the deep sea, survival depends on noticing small opportunities before they vanish. A long siphonophore colony drifts nearby. It may appear to be one enormous animal, but it is formed from many specialized individuals joined together. Some parts provide movement. Others capture food, digest it, or support reproduction. Transparent swimming bells contract in sequence, pulling the colony slowly through the water. Fine structures extend behind it, almost invisible in the darkness. A faint pulse of blue light travels briefly along part of the colony. Then it fades. The siphonophore continues drifting like a ghostly thread through the abyss. Other gelatinous creatures use transparency on an even larger scale. A giant larvation lives inside a delicate structure formed from mucus. This transparent house can be many times larger than the animal itself. The larvation beats its tail, drawing water through the structure. Food particles are captured by fine internal filters. When the filters become blocked, the animal abandons the house and creates another. The old structure begins to sink. As it descends, it carries trapped organic material toward deeper water, providing food for creatures below. Even the most fragile animals can influence the movement of nutrients through the ocean. Not every deep-sea ghost is transparent. A black dragonfish moves through the darkness with skin that absorbs almost all available light. Instead of allowing light to pass through, its body prevents light from returning to the observer. Microscopic structures within the skin trap incoming illumination. The animal becomes darker than the surrounding water. Only a few tiny photophores remain visible. When the dragonfish turns away, even these disappear. Its body seems to dissolve. A viperfish uses similar dark coloration. Long teeth curve around the outside of its jaws, allowing the fish to close its mouth despite their size. Its body is narrow, and its movements are slow. Food may be separated by enormous distances, so energy must be conserved. The viperfish does not swim continuously in search of prey. It waits within the darkness, using sensitive eyes and faint light organs to detect movement. When an opportunity arrives, the response must be fast. But most of its life is spent in stillness. Farther below, an anglerfish hangs almost motionless. Its body is dark, rough, and difficult to distinguish from the surrounding blackness. Above the mouth, a thin spine ends in a small glowing lure. The light is produced by bacteria living within a specialized organ. Only the lure is meant to be noticed. The predator itself remains hidden. In a place where meals are rare, a small animal may investigate any sign of possible food. The glow moves gently. The anglerfish waits beneath it. The deep sea rewards patience. It also rewards efficiency. Many animals possess soft bodies and weak muscles because powerful movement requires too much energy. They may wait days or longer between meals. Growth is slow. Encounters are rare. Every successful feeding opportunity matters. Near the abyssal floor, a tripod fish stands above the sediment on 3 elongated fin rays. Its reduced eyes are of little use in near total darkness. Instead, long sensory fins detect vibrations and movement in the current. The fish faces into the flow, waiting for tiny animals to drift within reach. It does not search across the plain. It allows the water to bring food toward it. Pale sea cucumbers move slowly over the sediment. Some are almost transparent. Others rise into the water and swim with delicate movements before settling elsewhere. Brittle stars spread their arms across the bottom. Small crustaceans hover just above the surface. The abyssal plain appears empty only because its inhabitants are widely scattered. Food is too limited to support dense crowds. Distance is part of the deep-sea landscape. One animal may live hundreds of body lengths from the next. Communication becomes difficult. Finding a mate may be as challenging as finding food. Some species use light signals. Others detect chemicals carried through the water. Every adaptation must operate across darkness and distance. Yet even here, camouflage remains important. A transparent animal avoids creating a silhouette. An ultra-black fish absorbs stray light. A silver body reflects the faint blue above. A glowing underside erases a shadow. The deep sea contains many opposite solutions to the same problem. How can a living body remain unseen in almost complete darkness? As the camera pulls away, the animals begin to disappear. The glass squid becomes a faint outline. The amphipod vanishes among marine snow. The dragonfish is absorbed into black water. The anglerfish lure remains visible for a moment, then dims. What seemed to be a collection of strange creatures becomes an empty abyss once again. But the darkness is not empty. It is filled with life shaped by pressure, hunger, cold, and the smallest traces of light. Here, the ocean's ghosts continue their slow journeys, present everywhere, yet almost impossible to see.
regions. Here, just beneath the waves, the juvenile California flying fish finds sanctuary. Its